Here we have a local towing company that charges $3.50 per each mile that you're towed, plus they charge a reservation fee of $12. They will only tow your vehicle a maximum of 30 miles. We are to write a function, a total cost function, C, as a function of X, which is the number of miles that my car is to be towed. When we write our answer, we have to use function notation, and we have to write a formula, or if you want, we have to write an equation representing the total cost to tow the car X miles. So notice there's no explanation here what kind of an equation. So it turns out that since the charge doesn't change, that each mile I'm being towed is the same, it turns out that this is a linear equation. But to sort of justify that, sometimes it's easier to justify if you let me write a table of values to clearly show how the growth of the cost function is growing. So I'm going to define my inputs here as X, and it's going to be number of miles driven from the towing company. And I'm going to define my output to be C, or if you want in function notation, it would be C of X, and that would be total cost. So you have to know that it's total cost as opposed to something else. It's not the total cost just per mile, that would just be $3.50. This is the total cost of the towing, and that would be my output, and it would be in dollars. So the first part is a little hard to justify. The idea is if you walked in there and asked them to tow your car 0 miles, in real life they'd say, well, we're not doing anything for you, so the cost would be 0. But you kind of have to play along. Think of this as you're going to get your car towed, but you want to know what the flat rates are. That give me the money that I'm going to have to pay that has nothing to do with the number of miles I'm driving. So I want a function that when I plug in 0 miles, the only thing that would remain is the amount of cost that involves any flat fees or insurance or anything that has no correlation to my input variable miles. So you have to play along and notice that that would be the reservation fee of $12. So the idea is in my equation when I plug in 0 miles, I want it to say $12 is my flat fee. So then what happens is if you were to increase this by 1, let's say we add 1 mile to our journey, well now you're getting towed 1 mile, so you're still going to pay that flat fee of $12, but in addition to the $12, as the story goes, you pay $3.50 for each additional mile. So I'm going to leave that there. The students are usually trained to simplify this, but if you simplify, sometimes you lose the pattern of the growth here. So now what I'm going to argue is, what if we get towed another mile after that? So that would be, add 1 more mile and you'd get to 2 miles. And you could do the arithmetic, but again, I'm trying to show a pattern here. The idea is that you'd have the original $12. We've already added on the $3.50 for the first mile, so if you wanted, you could do that. So now what I have here is the flat fee, the $3.50 from being towed the first mile. Now I have to add on the $3.50 that I would be towed for the second mile. So if you looked at these numbers, you'd see, first of all, that it is constant slope, that my change in y over change in x is constant. Now in my problem, I'm not using y for my outputs. I'm using cost, and I'm not using, well, I guess I am using x for my input in this case. And this would be in dollars, right? We said that the cost is in dollars, and the miles driven, x was the number of miles towed. So notice that my slope, if you looked at the units, would be in dollars per mile. In fact, whenever you see a fraction in mathematics, a lot of times you'll hear me use the word per to represent that. So this is dollars per mile. So this is exactly the cost per mile. So it's going to be $3.50. You can get it just from the units, or you can say that the change in cost from here to here is $3.50. From here to here would be $3.50. And I was choosing my inputs to increase by 1. So there's my slope of the problem in dollars per mile. I can also pull out the y-intercept of the function. The y-intercept of a linear function is the output that you get, question mark, when the input is 0. And we have that already. We have that if you plug in 0, the output is to be 12. So I have everything I need to write an equation. You could write it as y equals mx plus b, and at the end we need to pay attention to the fact that we're not calling our output y, we're calling it c of x. So we'll change that in the end. So I've argued that my slope is 350. One way to think about it is your slope is always the amount of increase in the output for every unit increase in the input. And my inputs were increasing by 1 unit. And by increasing my units, my input by 1 unit, my output was increasing by 350 each time. In fact, to get from this to this, I added 350 a second time there. So the pattern is y goes up by 350, x goes up by 1. Y goes up by 350, x goes up by 1. So that's my slope, 350. And my b value would be 12. And maybe I'll finish this. I want to back up though, because I did this pattern on purpose to show you something that sometimes my students think are really cool. You were just sort of told this in school. You were just said, memorize a line as y equals mx plus b because it works out. So you just do that. So I'm hoping when I'm done with the video, if you have the patience, you really want to understand why it is that way. I'm going to go back and show you. But remember now, I'm supposed to write my function in, function notation. So I need to replace y with the output variable c of x, and then that would be my function notation. And you could leave it like this. It would also be correct if you actually kept the y there. Now, it did say to write a formula, and then I replaced that word with equation. I think these two words are synonymous. When I teach math, sometimes I'll say write a model. And if they say write a model, what a model is an equation plus a little more. So if I was just to hand you this with no story, you'd be kind of lost. If the video started with me writing this equation, you'd be kind of lost as to what this gives you. So you would probably, if you were to write a model, want to tell people within the equation what the units are. So since, and this gets a little technical, since this is my output variable, and since it's equal to all of this, I argue that since this is my output, that all of this is my output as well. So the idea is if you were to plug a number in for x, this would simplify out, right? You'd multiply by 350, you'd add 12, then the idea would be this would be a single number and it would represent my output. So this is in dollars because it's my output. So what we commonly do is write dollars here to let people know the cost is in dollars. And it's a little confusing because it seems like you need parentheses. It's not just the 12 that's in dollars. It's meant to be this entire output would be in dollars. And then we usually say what x is. So we'd say x equals number of miles towed. So I'm not sure that you need all that when they ask for a formula. I've always thought of a formula as an equation, but certainly if they say find a model, they're always asking for the units and the meaning of the input. The units are number of miles, the meaning is towed, miles towed, and then we put the units on the output. So done with the video, but if you're interested why y equals mx plus b comes out, don't stop the video and let me clean this up a little bit. So the idea is, let's think of this as 12 plus 350. Let me write out one more. I called this, since it was towed 2 miles, that the flat fee was 12. You paid 350 for the first mile, but now we have to add on 350 more for the third mile. Maybe I'll leave it at this. So I don't know if you noticed the pattern of the outputs, but I can write all three of these statements as 12. Notice that all of my outputs start with the number 12 the way I've written them. And then they all have a plus, if you will, in there. I guess the first one doesn't, but I'm going to put something there in a minute. You could actually represent repeated addition with multiplication, meaning that if you add the number 3.5 twice in mathematics, what you can do is you can write the 350 and just multiply by 2. That's the definition of multiplication. If you have 2 times 350, that means you're adding 350 twice. Then I would argue that this thing can be written as that we added 350 one time. And then if you want to be technical, you could think of how many times did I add 350 to this number? Well, 0. We added 350 0 times, and notice that would still work. 0 times anything is 0, so this would be 0 plus 12 and give you your 12. Well, this continues on. I mean, if you are towed 3 miles, then the flat fee is 12, and then you pay 350 for every mile, and in this case, the number of miles is 3. So when you go to write your equation, I'm feeling that we probably just train our students to use y equals mx plus b, but you could say this, c of x, this is my c of x here, right? My c of x changes every time x changes, but there's a pattern to that change, and the pattern is that they all start at 12, they all have a plus, they all have a 3.5 in them, and the only thing that seems to be changing at all in this problem is the number in the parentheses. And if you notice, the number in the parentheses is always exactly the x value, right? There was a 0 here and there was a 0 here. Here there's a 1, here there's a 1. So the number in the parentheses depends on the x value chosen, so we put an x here. So in a way, I wrote my equation y equals b plus mx, and some students insist that it has to be the other way around, but it doesn't. In mathematics, addition is commutative. You can flip it around. So if you feel the need that you just have to change that around because we beat it into your heads that it's y equals mx plus b and not b plus mx. That's a terrible b up there, isn't it? But you get the idea. The idea is I like that explanation. Now the problem is we don't want to do that on every single math problem because it's just too cumbersome to write these things out. But at some point in your mathematical career, someone should show you why linear equations are the form they are. And I'm not sure it necessarily helps you get better grades, but it certainly shows you where the mathematics came from. Someone in the world at one point in history wasn't told that this is y equals mx plus b, and they had to identify what was going on. This is just one way to do it. I doubt that this is the way they did it, but this is one way to do it. So hopefully you liked that part of the video. It made me happy explaining it.